Hello, hello, hello. Ciao, Matteo.
Hello, hello. Hi. Ciao, Luca. And welcome
The
back.
fall is here, and
Yes.
my sinusitis is proving it. So sorry for the terrible voice, but I'm an innocent victim of my chronic sinusitis. So anyhow, I hope I will make it. But today is pretty exciting because we're gonna talk about actually the beginning of Platformatics success, so we say.
Yes. I would say yes, success or waste or avoiding time wasting, but this is I'm jumping so fast. So yes. Let's go and start about that.
Yeah, and for the people that are kind of like also watching our video, sorry if I'm dipping my tea the whole time, but that's the only thing that clears my nose. So today we are talking about clients, actually HTTP clients. And I remember the day that I told you that I asked you the question, why in Java is as simple as a right click and create client, and in Node it always takes an infinity amount of time. And it was, I think, May 2023, 24? No, 24.
Yeah, something like that, 23.
23. And we yeah, it was 2023, was June. And we started creating what was Platformatic client.
Yeah, well, let's go and talk about the problems, okay?
Yeah.
Which I think it's more important for
let's talk about the status quo, then the problems, and then we go.
Yes. So, okay, let's talk a little bit about the status quo for a few things. So, first of all, you have been building you have a Node.js app or a JavaScript front-end application. Okay. Either one of those. Okay. We'll keep them separate. We'll talk a little bit about separate why in a moment. But you have both. Okay. You have one of those two things over there in front of you. Okay. And you need to integrate a third-party service. Okay. Now, what I have seen most companies do, okay, is coding those, they call for that integration manually. So there was, in a few projects in the past that I worked on, there was an engineer whose job was to write the clients for the HTTP services or graphical services or gRPC services. And he was taking them and saying, okay, this is the contract between my service and my application, and then writing the code using the native drivers. So you can use, HTTP.request or Axios or something like that to call the other service. Okay. And essentially their job was this was their job. Okay. They essentially moved, and then if there was a parameter to change, they changed the parameter and so on and so forth. Okay. Galactic waste of time. Okay. Frankly. Then Luca asked me that question, and then I started researching why that was the case, okay? And why there was no real good generators for this, okay?
Well, there were some, but they were terrible, right?
I mentioned good. Like, okay, so there was a few problems with the
Define good. Yeah, define good.
So first of all, we have two different set of requirements, okay, that cannot be satisfied by the same library. The requirements of the front end and the requirements of the back end, okay? The two requirement set are different, okay?
Yeah.
One, the key things for the front end is having the bundle generated, the code in the bundle as small as possible while being type safe, okay? So you need to be type safe to begin with. Okay, you need TypeScript integration. You want to be able to very quickly a developer be able to discover those APIs, use those APIs, and so on and so forth. Absolutely needed. Okay, this is the first case. Okay.
Yeah.
On the servers, though, okay, you really should and would and probably have to and must use Undici if you want to get any good performance out of your HTTP calls, okay? the difference between that and something like Axios or GOT is so big, or even just fetch, to be honest. You want to use undici.request to be able to handle the intricacies of doing HTTP calls at scale in a microservice network. It's very tricky.
To say why briefly, why Axios or GOT? Why? I mean, why should I use Undici versus this? Not on
Undici.request. Okay, well, the fundamental point is Undici is built to separate the API layer that you use, okay, to make the HTTP calls with the underlying transport logic, okay? While old school HTTP.request, which is what all of those other libraries uses, is not built for that, okay? And essentially, it's a better abstraction, okay? And because of that, you want to be able to tune keep alive connection timeout. You want to be able to tune how your caching would work. You want to be able to tune how your retry won't work, but at a lower level possible to minimize overhead. So the critical part here is overhead. You can do all those things with Axios, just with a way, way higher overhead on top. So Undici was born to make a node fast. There is a few talk from me that talk about Undici and fast HTTP requests. But the key part here, the key logic is you want to use Undici.request. The benchmarks are talking by themselves. Okay, there's literally very little excuse to not use it. Okay, you should be using it. Okay, so you really and to avoid a hell of a lot of problems. For example, let me explain one of the problems that we were able to fix very recently, okay? Imagine that you're deploying your application on Kubernetes and you notice in your open telemetry tracing data that you're spending a lot of time waiting for DNS to respond. You could easily turn on DNS caching at HTTP level with a one-line code change in Undici, and you can't really do that in with Node Core HTTP request. So it's actually built for solving real enterprise, real company problems in deploying HTTP at scale. So,
question: why not merging Undici inside of Node Core? That's better.
Good question. So very big. Undici is part of the Node.js ecosystem, okay? Mm-hmm. It's essentially born out of the frustration of most of the Node.js HTTP team in maintaining HTTP.request, which everybody will consider as legacy at this point. And it's also part of Node.js core in the form of fetch. It's underlying transport layer of fetch, okay? Why? Because in this way we can support HTTP 1, 2, and so on and so forth in a transparent way. It's super flexible, but also super performant. Okay, fetch though is due to other things is still very slow. So,
and I have a question because we are talking about clients and so on, but I will not name them directly, but you know to whom I'm referring to. Let's say that also in the past probably years, we saw that huge trend about building SDKs out of APIs, right?
Yes.
But where do you see actually the SDK narrative falling short against building, for example?
Like from my point of view, okay, let me rephrase this. This is actually it's very provocative actually, your question, Luca, as usual. Come on, this is actually a very provocative question, okay? So,
that's why
so SDKs, okay, you have SDKs, okay, and API generators, okay? Now, I am of the opinion that an SDK, in order to be well integrated into the language that is supposed to target, okay, cannot be automatically generated, okay? Some of it maybe can, okay? You can probably automatically generate some part of it, okay?
Yeah.
But in order to provide the level of polish that your project deserves, you have to, or the performance that your project deserves, okay? You have to manually code it, okay? Why? Let me make a clear example, okay? the AWS SDK is automatically generated. Okay, the AWS SDK is automatically generated from the same specs from which they generate the Java one, and so on and so forth. It's a fantastic pipeline. Okay, the pipeline is like, it's a feat of engineering, to be honest. Okay, on itself. However, the AWS SDK is also dramatically slow. Okay,
Oh.
it's dramatically slow. Literally, we were able to cook a very specific and narrow client for S3, for example, or for Dynamo, with incredibly higher performance throughput compared to the AWS SDK one. Okay, and the AWS SDK team totally say, "Oh, absolutely! Look, absolutely, this can be optimized, but it's not on our goal." Okay, our goal is to minimize maintenance cost. Okay, so to be clear, the gap at this point in time is how much it costs to create the SDKs for each one of the platform, the runtimes and the platform, and how much I want to spend into optimizing them. Okay, and look, this is a business decision, to be honest.
And I think this topic is kind of like very dear to us, right? Because we both believe that the generalization of technology brought us to basically having technology that are meaningless to the real business goals of the final enterprise. If you look,
to be honest, if you want to build delightful experiences, you more or less you have to specialize somewhat. You cannot avoid specialization, I am afraid.
No, also for performance, for reliability, for taking the most out of other technologies, right? If you think, for example, about Docker, right? It's the clear example of that abstraction that was great to accelerate the initial inertia, right? But at the same time, I think it brought us into this kind of like vortex of like equalization of any technology. And then, I mean, it's great for us because it creates an opportunity. But on the other side, imagine everyone that was kind of like the bead on the bait, right? And at the same, I agree with you, is with SDKs. I mean, there are some interesting companies that they made a business out of it. But I'm curious about the performance. I'm curious about the whole journey that will. And now you see it with MCP, right? Everyone is like jumping into this MCP generalization, right? With the AI gateways or with everyone is brewing their own agent library. And we saw like recently a couple of, horrors and crime against technology being built by people. And the problem that these things are going to go into production, right? Better for us, but anyhow, I was provocative enough, and I think you got the references.
I got the reference, Luca. So let's go back to client generation. Okay, so client generation, it's very critical. It's so at some point, okay, Luca was asking me that question, and then I went back to asking my team, okay, hey guys, how long does it take to write that client, okay, and to update it? Oh, well, I don't know, to write a new one, maybe a few hours, and then, I don't know, I need to update it every time there's a new endpoint, maybe, I don't know, a few hours a month. And I was like, okay, we are doing something about it. We can't waste this time, okay? This is not a debate, okay? We need to fix this. This is a galactic waste of time for my team and also for all of you, likely, okay? So we went on that direction, okay, into automating all the things and adding a generation. Now, we use for all of these OpenAPI a lot and JSON Schema, okay? This means that we could actually generate them type safely and create a lot of very good, create all the needed, TypeScript logic so that everything is type safe, essentially. And look, it got us somewhere well. I would say we have companies using it, and a lot of our internal team is using it, and it works relatively straightforward, to be honest.
Well, we use it everywhere, so
we use it everywhere. So for our internal purpose, it works perfectly. Okay, and so it's actually a very good point and a very good idea. And instead of right-clicking, I'm sorry, Luca, you need to run a command and you get a client, which is...
Then you can still do it if you write a Visual Studio Code extension, right?
Yes. We never ended up doing that, Luca. We talked a lot about it, but we never ended up doing it.
No, we just said people can write one line of code. But so the main problem, I think you touched it, right, is that in a microservices environment or in any environment that requires integration, you have a cost of maintenance in that integration that reflects on making code usable, like you were saying, but also B, in having fault detection done as soon as possible, right?
Yes.
So when we built Platformatic Client, our main goal was can we actually make it part of a CI/CD pipeline, the code generation?
Yes.
Can we have that integration where if I connect to an API and I generate the client and something goes wrong, I can detect it right away through my unit test or whatsoever?
Yeah.
So maybe you can explain why the thing works, right? Maybe let's go a little bit on how Platformatic Client was designed and born, because I don't think we revealed the secret behind Platformatic Client.
Oh, like the fundamental part here is how do you generate TypeScript in a easy to maintain way without wrecking your head on the internal TypeScript APIs. Okay. We ended up using a very, very basic form of code gen, in the sense of we are not working the TypeScript AST, we are not allocating nodes. We are just, writing TypeScript and then having concatenating all the strings and really heavily relying on integration tests and unit tests to catch any problems. So that is actually how we do this. This is actually proven viable in a long-term fashion. It's great for all intent and purposes, because we can cook it up very quickly. We can maintain it. The actual code to do the generation is low. Okay. We create two different things. Okay. One is for front end, which is based on fetch, relatively slower, but no dependencies, very tight, very tree shakeable, so very little code at all for you. Based on fetch. Okay, these works also in Next or Next, whatever you want. Okay, we also have a module which is a runtime module which is based on undici requests. Okay, that is essentially, most of it is dynamic. So you just need to point to the file, to the schema file. It will generate it, load it, generate everything. Look. At runtime, but also you can, it will also use the generator to get the types for it, because they're very handy and useful, but no need, essentially, in case you're just using plain JavaScript, you can completely avoid that part.
And you mentioned about type safety, right? Because I think it's very important. Well, for two reasons, right? The first one is clearly the developer experience. And the other one is the whole maintainability, like we were mentioning, and onboarding, right? Because where do you see actually the kind of like role of TypeScript in all this new wave of HTTP clients? Because long time ago, when there was no TypeScript, the problem was still there, right? In Java, you have XSLT to validate.
Yeah.
But or you have your
let me make an example, okay? One of the problems, okay? One of the problems on writing SDKs or clients, okay, is guaranteeing that the data you're sending is correct and the data you're receiving is correct, okay? You can guarantee that the data you're sending is correct via type safety, okay? Because you can guarantee that those are the parameters, they're called this way, this is the syntax, and so on and so forth, okay? TypeScript gives that to you, okay? Minus box, whatever, but TypeScript gives that to you. However, on the data you are receiving, you can't do anything, okay? You have to you need to validate the response, especially if you are connecting to a service that you don't own, because you have to validate that the response is actually coherent to what you have written, okay? You need to have a schema. You need to load the schema of the response locally and validate that that result is the same, okay? You don't want to do that on the client because it's a lot of code and work and CPU cycles and so on and so forth. Not needed in the client. But on the server, you really want to do it, especially if it's from another team or if you suspect there is a bug, okay? You can do that and validate that the response is the same and so on and so forth. So by including the schema generated inside the service, you can do that, okay? And otherwise, this is a massive problem, especially with JSON and REST, because you can have somebody violating the contract and never knowing about it.
And I mean, you mentioned the JSON schema, right? Mm-hmm. But let's maybe kind of like talk about the role of OpenAPI and all these specs in the world of client generation.
Yes.
I mean, as you know, we are involved with OpenAPI and so on. So we deeply believe that the standard itself is massively helping enterprise to kind of like define a more conform, a more kind of like standard way, right? But in terms of like the client, because you mentioned that we support both GraphQL and OpenAPI.
Yes. So
what is the difference?
Okay, our support for GraphQL is, I would probably call it minimal, okay? Mm-hmm. It provides essentially a decent wrapper on top of it, but we are not providing the same level of integration that we are having for the client, okay? For OpenAPI, okay? For two reasons, okay? First of all, with GraphQL, the client has the control. So the user is the control. I would need to specify what are my queries, okay?
Yeah, which is
in GraphQL. Right? In GraphQL, no, it is realistic. It is an approach, okay, but that is best done probably with some specialized tools that we never got to write so far. Okay, we might probably do it. It's just we never got to it. Okay.
I mean, you could do it through query analysis, right? You could analyze the queries and do
exactly. You need the step. You will need a step where you say, okay, I have this batch of queries. I want to expose my queries. Okay.
Yeah.
And each query gets its own function and method and parameters, and everything then would be perfect. Okay.
Yeah.
And it can work. Okay. It's but you will need to specify the query as separate files essentially to be able to do that. And we felt it was a little bit more complex. So
yeah,
but it's totally possible to generate all of that. Okay. Now, on OpenAPI, we can be way more detailed because all the information is part of the definition. Okay. So we can essentially create an operation for each one of the routes being exposed via OpenAPI, and it's more granular. Okay. On the other hand, it means that there is a lot more endpoints to match. Okay. So there is the two.
But it is closer to what Java people would expect, right? Or .NET.
OpenAPI, yes. OpenAPI is close to what they would expect. GraphQL is probably close to what front-end developers will need. There is also a problem, though, and this is why we never did it, okay? Because of the so-called waterfall problem of GraphQL clients. So essentially, the problem is when rendering, okay, you you want to be able to coalesce all your GraphQL calls via fragments into one single GraphQL request, okay, through various components. So otherwise, you will do a GraphQL request, then wait for the next one, wait for that response, render a bit, then wait for the next one, render a bit, and so on and so forth. And you don't want to do that. You want to be able to coalesce all of them together into one single big request with all the data. So hard stuff, okay? I was recently at GraphQL last week, and there were a lot of talks from very interesting talk about this problem, and a lot of different opportunities and takes on how to fix it, which is great because it means that a lot of big companies are working to solve this problem. So I'm very, very excited about it, to be honest.
But let's maybe look into some real case war stories about where basically clients or where self-maintained clients, SDKs, they kind of like
oh yeah, absolutely. So the worst one, okay, was a long time ago when to be honest, when Undici was born, okay, where the users were essentially have massive problems, okay, and everything was falling apart, okay. Two problems they had. First one was DNS. Dang.
Yeah.
The DNS, they were making so many HTTP requests that they were saturating the DNS server. Because Node.js by default does not do any DNS caching. So, dang, this is the problem. First problem. Second problem is they were always closing always making the call without keep alive enabled. So they were destroying and recreating the socket of each time, okay? Oh, but it gets worse to the third problem, okay? They were not implementing any form of TLS context, TLS session caching, okay? So even when reconnecting, they were creating a new TLS session every time. So at some point, the whole system gave up, okay?
Yeah, clearly.
So, like HTTP is logically a stateless protocol, but practically is totally stateful because it has a TCP connection underneath, okay? And even with HTTP 3 and Quick and everything, it's still a stateful protocol, okay? Because you have state related to the various streams that have been moved with data and so on and so forth. So it's stateful, folks, okay? It's a stateful protocol, okay?
But they sold me a stateless.
Luca, I mean, these are all things in life. Okay, everything is sold for something that is not, and I am,
I got lied.
Well, yes.
That's.
But they told you from the beginning it's a stateless protocol on top of TCP, which is stateful.
No, they sold it. The marketing was good. The marketing was good.
So
they also sold me other stuff.
The key point is on why it's stateless, okay, is because logically it's stateless, okay? There's no state involved in maintaining the connection, okay? And you can put different requests through the same connection and reuse it all the time. At the beginning, it was one connection, one request, but then everybody realized that in order to be performant, you cannot destroy the socket every single time. You need to keep those things open because they are expensive. So,
for a second, I got this flashback, Theo, when we were kids, of the Chef Tony and his knife. That was then the same.
Okay.
You remember when he was cutting the can of Coke, like with the knife, and they said he can cut.
You watch too many ads, Luca. You watch too many TV ads when you're,
And I also bought the knife.
No, you bought it. Come on.
I was too curious. I needed to see if it really could cut the Coke can.
Did it cut the Coke? Was it able to cut the Coke?
No, and not able to make.
So you were scammed. Okay, good.
Yeah, but I feel the same with protocols and with other stuff. So, and in the integration world, right? Where did you see this thing breaking apart? That where type safety instead helped massively.
The fundamental problem here is about developer efficiency. Okay? You want something that is easy to debug, okay? Not a lot of code, something that everybody can understand, as close as possible to what you would write by hand, okay?
So not an SDK.
You said it, yes.
No, I take responsibility.
If I create an SDK, you want the manual curation so that you get a carefully curated experience on how to use this. Now, I open an SDK for Node.js. It's written for Node.js, okay? And usually my answer to that is, well, it's probably better to throw it away and writing it by hand. You're going to get much better performance out of it, okay? Either in connection management, retries, and so on and so forth, okay? It's day and night, to be honest, in terms of what you can get out of, the defaulted SDK and stuff, and so on and so forth. Usually they create something very generic.
Yeah, because I saw some of them even creating Terraform out of APIs. I would not be surprised if next week there is something that can build I don't know, a farm out of
Luca, now I'm putting a Claude agent to write me the generator, the Terraform generator for APIs. Come on, we should do it.
So Cloud agent, which means MCP. See, we're back. We're back at the crime against the technology.
MCP. Well, yeah, maybe.
I don't know, but that's kind of like interesting. To me, I was reading something recently from Augusto that says that the UI, Augusto Marietti from Kong, which make me actually think on something that Einstein said a long time ago. I'm not going to reference, not to insult anybody, not knowing what Einstein said. And when they say that basically UI will not exist in the near future because system will communicate in a way that we cannot comprehend right now. And I think actually that's a very interesting view, right? And if you see how the systems are going to communicate with each other, and especially we are talking about HTTP clients and the abstraction between the system-to-system communication. That's an interesting view, but at the same time is also a kind of like dumb view that is going to remove. I still believe that all those interactions they will need, no matter what, to be humanly maintained.
There is a few bits. I don't think we are anywhere near, okay, that moment.
I agree.
And I don't think it's ever going to go away, specifically because you still need, let's put it a transaction, as a typical system, okay? What do you do, I don't know, monthly? It's a task that you do monthly, okay? Or a lot of people can even do weekly, especially if they have a kid, okay? You need to send wire transfers or pay various random services through the week, okay? And you need to go to your bank and do the transfer.
Exactly.
Okay? Now, would you trust a probabilistic system to do it?
No, but think
like there is no way that like you don't want, if a mistake is made, the human in charge wants to be responsible for making that mistake.
But Matteo, I think it goes actually beyond that. If you think that banks in the so-called digital revolution, right? And that's why I think it's a very myopic and very kind of like narrow-minded vision of the world. There are places where, and I'm not talking about third world country. I'm talking about Italy, talking about Germany, talking about France, Spain. You know that if you go to the bank, they still print out the transaction request and you need to sign it, and they check your signature.
Yes.
Right? You know that in USA, in United States of America, where many of these people are citizens and they have this beautiful visionary thing, they're still doing checks.
Oh yeah, I know.
And they go and pay a donut with a check because that's allowed. Just saying, huh? Like
Anyway,
in Canada, the same thing. So
we are.
I think no, I think it's not really divergent. It's really important to kind of like stress our point that there is no escape from these clients, and no matter of what kind of like dimension in the universe, space and time you are, those clients needs to be generated, needs to be maintained, needs to be honestly cuddled and, you know, kept alive.
Yeah.
And I think like the reason why we wanted to chat about clients is that they are an important, if not fundamental, component of this new modern visionary trend where systems will like intelligently communicate with each other, but they still need a way to handshake this communication, and that we like it or not.
I think the key part here is anyway, we're going back to AI and we shouldn't, Luca. So,
but everything is about AI.
I mean, I know.
People will actually argue I can generate your HTTP client with Claude, so I don't need your client.
Look,
right?
It's. I don't think it's ever going to happen. Okay.
Why? Why?
It's probabilistic. Okay.
Exactly.
So right now, like,
would you trust that?
Wait a second. That's not true. Okay, that's not true. If I think these long term might work. Okay, with these long term might actually be valid use case with minus a few big problems. Okay.
What do you mean? The use of AI to generate those clients?
Yes. The first big problem is the cost of it, okay, which is not non-trivial, okay. The second one is you still need a human to review the thing, okay, and the third one, it's not deterministic, okay. So you don't know the output. So
I know somebody that is both on our LinkedIn, one of my inspiring muse. That probably will argue with that because recently this person wrote, the AI is not wrong. It's you that you don't know how to give the AI the right context. So the problem is always the human, right?
Of course, it's the human. But again, it's the problem. Genetic problem is.
It was very sarcastic.
If it's 101, okay, like you want your client, okay, to be able to generate, okay, very good, in a very programmatic way, very good clients, okay, very cheaply, okay, that you can essentially, with the service definition changes, there is a new service definition happening immediately, okay. So you do that and do all the time, okay, pretty amazing.
Yeah, I think just because we are running at time, but I think where I see really the future evolution of clients is not really their generation, but I think where AI can really help is to write all the different unit test and integration test, right? That's the kind of like thing where
it's a lot. It's relatively a lot. It's a significantly amount of work. Okay. On this topic, okay, let me signal 2 bits that are how do you unit test these kind of systems, okay? So the first thing that you want to unit tests, okay, you can write your unit test is you need a way to mock the target service, okay? You need a way to do unit test by mocking the service. You have 2 ways. We have 1 way. So mocking is a first-class citizen in Undici, so you can actually do the mocking in Undici itself, okay? It's a first-class citizen, so it solves the problem
with inject.
No, it's just Undici. Basically, because of the modular stack, okay, you replace the stack that does the agent that does HTTP calls with the agent that doesn't do HTTP calls.
Okay.
It's literally built in a way that you can literally swap it out and swap that in, and it all works perfectly. So this is what makes it Undici really efficient, but also modular. Okay. So there is that. I recently opened a thing. Opened a PR to add snapshot testing. So you could essentially do a snapshot, run some tests against a live service, take snapshots, and then replay it from the snapshots. So it's
with R or with pure.
Our own internal format. R is it was very complex to implement. It's and so it will require massive amount of work to make it happen. Possible. But it was hard format was not a requirement, so we didn't do it hard format. But it will be cool to do it in a hard format as well. To be honest, I'm not. It's if you want to discuss it, folks, there's an open PR. Look, if you have time, you can crack it. You know.
No, I've been having a lot of fun doing other stuff, but still cracking, but something else. Anyhow, I think we are at time, Theo. It was such a great chat. I'm looking forward to our next week chat, hopefully without my beautiful sinusitis. And till then, have a great rest of the week and see you next week, Theo. Ciao.
Oh, and by the way, guys, use Massimo. Massimo at http.dev. You can try it out. You can let me know what you think about it. Okay? I can't wait to hear about you. Bye, guys.
Ciao, everyone. Bye-bye.
Ciao.